Now, let's look at a few interesting points which drive this world of reinsurance. See, apart from knowing how much is the mean amount that is paid by the insurer and the reinsurer, what is the variance of the payments that are paid by the insurer and the reinsurer, what are the typical distributions of the payments that are done by the insurer and reinsurer in case of, let's say, excess of loss based reinsurance as well as proportional kind of a reinsurance, any of them. A few more interesting things which somehow find an interesting mention is how will we typically look at the same above stuff in case there is an inflation, and two, how do I really get into the estimation of the estimation, especially when there is a claim data that is used. What kind of models are used for estimating the parameters when there is an actual claim data that is being used? Then, how do I really correlate the policy excess or the deductible, finding out the mean as well as the variance, etc., with respect to these deductibles? How can I see how well they can be linked with this concept of reinsurance payout? So these are some of the things that we would like to look at here. Now, let's say we are talking about a claim amount X, but now let's say they are inflated by a factor K. So now the claims are becoming KX. But still the retention level, let's say, is still M only. That did not change. If that's the case, now what is the claim amount? Now the claim amounts are becoming KX. Now if that KX is less than or equal to M, the insurance company is payout full. So insurance company is going to pay out KX. But once the KX becomes greater than M, insurance company is only paying M, right? And which means the payout that is typically made by the reinsurer is nothing but the excess of X minus Y. So in some cases it is 0, and in some cases he is doing a X minus whatever is the M. In some cases he is doing 0. In some cases, or probably let me call it as KX minus Y. So he is paying KX in case kx is kx minus y. So reinsurer is paying 0 when kx is less than or equal to m, and he is paying kx minus m in case the claim amount is greater than m. So if I am looking at the mean amount in this case, what is the mean amount that is paid by the insurer? Okay. Now, what is the mean amount that is paid by the insurer? I have to typically, the insurance amount, the claim amount now is kx f of x dx. Now, x should lie now between 0 to m by k. As long as x is lying between 0 to m by k, he is paying a claim amount of kx, and if it is greater than that, M is what is being paid by the insurer, which means I'm looking at the probability that X is greater than M by K. So if we look at it, the mean is not exactly K times to the mean that it was the case earlier, because this part is incremented by K, but this part has not changed. So the new mean claim amount that is paid by the insurer, I cannot take it as K times the mean claim amount that he has paid when there was no inflation. Now, a similar kind of an approach can very well be planned out even if the retention limit is subjected to some kind of an inflation. Instead of now, if the retention limit instead of M, it is becoming some LM. Now the same kind of a logic can very well be planned out, right? Because as long as the X is less than or equal to LM, the insurance company is going to bear. And the moment X is greater than LM, it would be transferred to the reinsurer. So only LM is what is being paid by the insurer, and X minus LM is what would be paid by the reinsurer. So that kind of integrations resulting in computing the means can quite comfortably be addressed once the basic concept is known. So in general, we have to be comfortable with this kind of a concept where there is some amount of inflation that could happen either to a claim amount or to the retention limit. How well I address them to take those things into consideration for the computation of my mean claim amounts and the variance in the claim amounts. That's one dimension which we need to be comfortable with. Now, the other thing which I would like to bring in this context is how well I can estimate the parameters in this case, especially when I am looking at excess of loss based reinsurance, how well I can look at the parameters estimation. Let's see in general, when we look at the claims record, which are the list of actual claims that the company is having, it may have only net claims. It may not contain the gross claims, which means whatever the reinsurance arrangement that has been there, that would have been considered, and only whatever has been paid by the insurer, which would have been retention limits in some cases, or the typical claim amounts in some cases. So when the claim amounts are lesser than the retention limits, the insurer would have paid the claim amounts, but if they are more than the retention limit, the insurer would have typically paid the only the retention amount. So if that is the kind of a data that I have, and I really have to estimate the gross claims, the distribution that is associated with the gross claims just by looking at the insurer's record. Now, what kind of mechanisms I can use here? Let's consider one by one. Okay, how is the method of movements applicable here? So what are we doing in the method of movements? I am computing the mean of the data set, which is the sample, and I take the mean of the distribution, equate the two. But here I cannot compute the mean of the claim amount because the claim amounts are not actuals. Some of them are actuals, but some of them are truncated. Or here we actually call the word as censored. That's a typical term for these. Censored is a clear mechanism which says some of the values are recorded exactly, while uh, some of them I know that they exceed a particular value. Here they are exceeding M, but I don't know what is that exact value. This kind of scenario wherein this particular value which I know that it exceeds M, in terms of gross claims, it exceeds M because the insurer has paid M and the remaining portion of it has been transferred to the reinsurer. So here I know that M is the payment that the insurer has made, and definitely the claim amount is much greater than that. So in this case, we are looking at censored kind of a situation. Method of movement will not work here because I cannot typically compute the mean also. So there is no way I can equate it. Now, what about the method of percentiles? I can very well use, because especially if my M's are very few. If the M's are very few, which means there are a very few reinsurance transfers. So generally they are estimated like any claim that are beyond an M, those are the ones that are transferred to reinsurance, and anything below that they are settled. Now, if these number of claims are much more than these number of claims, I can probably look at computing the 25th percentile or probably the median or even the 75th percentile. Try equate the actual values coming from the sample along with the distribution related values, and I can still do the mapping exercise comfortably. And this works only if there are few reinsurance claims, but it can still be applicable. But looking at the third major mechanism, maximum likelihood estimate, we can quite comfortably apply that concept to censored samples comfortably. Now look at two parts. Probably wherever x1, x2, x3s are there, which are actual values, create a likelihood function of your parameter, which is exactly take it as xi comma theta, and you multiply all of them, whichever are the number of values that are lesser than or which are having exact values. But for any of the claims which are represented by M because they are transferred to the reinsurer, in each of the cases, the first of all, in each of the cases, it's only M that is getting paid, right? In each of these cases, it is M that is getting paid. So, depending on the number of such claims that are there, I can take the probability that in each of them, the probability that the claim amount is greater than M, I'll raise it to the power of M, which is the number of such claims which are having a value greater than M. So in this case, the complete likelihood function which contains two parts. The first part is those individual claims which are having an exact claim value. So if there are n such claims which are having exact claim value, I'll take the multiplication of all of them from 1 to n. I am taking the likelihood function of each of probability density function of each one of them multiplying, and if I am looking at all the remaining claims, I can simply take it as 1 minus of f of m comma theta. So this is what is the probability that each one of them is greater than m. So it can be any value. It's not one single specified value. So that's the reason I'm taking the probability of each one of them greater than m. I'm raising it to the power of number of such occurrences. So this is the kind of likelihood function, and I can very well go ahead in terms of doing the log likelihood and maximum and taking the derivative of this likelihood equating to 0, which would maximize the likelihood of occurrence and which would help me in terms of deciding my parameters of theta as well. So whenever we are seeing this kind of censored data, and if I have to really estimate my parameter, either I can go with the method of percentiles kind of an approach, especially if my reinsured kind of contracts are much lesser, or I have to rely on maximum likelihood estimation approach like this, wherein I would consider anything which is censored, I'll take it as the probability greater than the probability of that particular claim amount greater than that m, and I'll raise it to the power of number of such occurrences found, right? Then one more important concept in this same context is the concept of policy excess, which in other case we call it as deductible. It's a quite interesting concept which all of us must be knowing, and it is very common in case of motor vehicle insurance or in many of the property based insurance and accident based insurance. It's a very common feature, and as per this feature it is nothing but uh, uh, the insurer will start paying the claim. The insurer will pay the claim only if the claim amount is above a certain number. Only if a claim amount is above a certain number, which means the insured is going to retain, the policyholder is going to pay from his pocket any claim up to that level of L. Only if the claim amount crosses L, the insurer is going to pay X minus L. As long as the claim amount is less than or equal to L, which is called as the excess or a deductible, up to that amount, we see that the insured or the policy holder is going to bear the cost. Any claim amount that is greater than L only would be borne by the insurer. So the typical expression wise, we see that what the insurer is going to pay is going to be zero as long as the claim amount is less than or equal to L, and it is going to be X minus L if the claim amount goes above L, right? So because the insured is typically bearing some portion of the loss, even traditionally we see that the premium that would be charged on those kind of policies is much lesser compared to those policies on which the excess does not exist, right? Now, if I have to really see from the perspective of the mean and the variance computation for the insurer, for the insured, in case of excess, if there is an excess, if I have to see what is the mean, that is mean of the amount that is borne by the policyholder, what is the mean of the amount that is paid by the insurance company. Here, look at it exactly in a regular policy. Take it with respect to insurer and the reinsurer with a retention limit of M. This is exactly the same. Probably think of this person as the insurer, this person as the reinsurer, and this is the retention limit. You will exactly find the insurer, from an insurer's position, the policy with an excess is same as the reinsurer who has accepted the excess of loss reinsurance with a retention limit of M. And from the perspective of the policy holder, we could clearly see that the mean losses can be computed in the same way as that of the excess of loss reinsurance mean computed for a regular direct insurer. So what we could typically see is computation of the mean and the variance and the distribution of the claim amounts for the policyholder as well as the insurer in case of policy excess is exactly similar to that of the roles of insurer and reinsurer in a typical reinsurance contract, right? So all these conceptual parts really need to be very much understood, and the more and more these concepts get in depth, solving the practical numerical problems would simplify our understand would get simplified at a more convenient pace. All right.